In this video, you will learn how to write a simple unit test. Let's get started. Hey everyone, my name is Michaela Karen. I am a full-time iOS developer and freelancer. Let's get started learning unit testing. The first thing we are going to do is create a new Xcode project. So let's go to File, New Project, and then we are going to select iOS and then App. And we are going to call this Unit Testing, CWC Unit Testing. Put a team if you have one. This is your organization identifier, like always. And so it does not matter if we use SwiftUI or Storyboard for this project, because unit testing is about testing how your code works, not about the user interface, so the UI, and that's what SwiftUI and Storyboard is all about. So it actually doesn't matter which one we click. We'll go with SwiftUI for this project. Keep it in Swift, and then if you make a brand new project, we are going to include tests from the beginning. So here, when we do click on Next, you'll see we create the test target just automatically, as opposed to when we have a new project, or as opposed to when we have an existing project, we have to add them in a different way. For this example, we'll just do a new project, and the next lesson we'll use a project that does not have unit tests that's already been created. Yep, we can put that. Okay, we will create our new project on the desktop. Click Create. Okay, here is our brand new project that we just created. Let's go ahead and run the project. So I'll click Command R, and we will run and just build to the simulator. So I just have iPhone 13. Okay, so we run the project and we see Hello World, just text on the screen like we should. So let's go ahead and stop it for right now. And then we see over here we have two different folders. So we have CWC unit testing tests and then UI tests. And then CWC unit testing is the name of the project. So these folders, tests and UI tests, were added automatically when we went and checked the include tests part. It automatically adds both unit testing and UI testing, which is not something we are going to go through, but it automatically adds both for us. So let's just minimize that because we're not going to look at it for this example, and just open up this file. So we see first CWC unit testing test, and it inherits from XC test case. So this is the class that is used for unit testing for like iOS development. When we go in here, the first thing we see is import XC test, because that's what's used for all unit testing on iOS. That's the library that we need. And we see this @testable import CWC unit testing. So what this is our project. So when we look at our project like test case, our project target, it is called CWC unit testing. So we have to include all of our project code up here because it's actually not part of our test target. So if we go to the project settings, our different targets, so we have our actual app target, so that's what you're used to when you build iOS apps. We have a testing target and a UI testing target. So these are actually completely separate, like from our application. And you can see it's telling us like what our actual host, what our actual app is. So think of it like they're in completely different scopes. So that's why we have to import our own project into our tests. So you get this boilerplate code, and this is just an example of how to set up our project, how to tear down it, an example of what a test would look like, which is completely blank and it just has comments, and then testing performance. So for this example, we're not going to go through performance testing, so we're going to just go ahead and delete that. Let's look at these setup and teardown methods. So they tell you what they do. So we put setup code here, but what is setup code? It's code that we want to run before every single unit test. And then teardown is code that we want to run after every single unit test. Because with unit testing, you want your environment to always be the exact same for every single test that you run. So these two methods are called for every different kind of test that we have. So if we go to func test example 2 or 1, 2. Oops. And it doesn't have to throw, but it can. And we do this, and if we click this little diamond right here, this will run all of the unit tests for this project. But if we also go over to the left here, the 1, 2, 3, 4, 5, 6, button from the left is the test navigator. It's the little diamond one. We expand this and we can see our UI tests and our unit tests. So let's collapse that one for right now. And you can see we have 2 tests in this class, and that's what this one is. We see test example and test example 2, and you can see they also have little diamonds next to them. So this is how we run tests. We could run it by clicking the play button here. We could click the play button right there, or even just click this play button and it'll run the entire class. Or if we also go to, is it product? Yeah. If you go to product and click test, which is the example, which is the shortcut, Command U, that will run our entire test suite, which would include our UI tests. So we kind of don't want to do that at the moment because we don't want these ones to run. We could just go, actually, that's what I am going to do. Let's go and comment them out for right now. So you can see there's some extra stuff that UI tests have that a unit test doesn't. Let's comment that out and go down to this one. Comment that one out, close that one, and okay, so now if we go back to our test target, these exist, but you can see now they don't have any tests in them because we just commented all of them out. So now when we click Command U, you can see now it's testing, so we are about to run our tests. We can bring up the console at the bottom. And on my computer, wait for them to run. Here we go. Test succeeded. So you saw this pop-up that said test succeeded, and you can see in the console it says all tests started and then all tests pass. We don't have assertions on these, and you can see they passed because we have check marks next to our 2 tests now, and we can see on the left that all of our tests have passed. But they passed because we're not doing anything, so they just passed like automatically. Let's go back and look at setup and teardown because there are a couple methods as well. Setup, is it going to do it? There we go. So if you type setup and just hit enter, sometimes you'll get this override class function, and that is not what we want. We want just the override func setup because there's actually a couple setup methods. There is setup, and then there's setup with error, and then there's also an async setup. So you use whichever one you need depending on what test that you're running. If your code does something asynchronously, or you need to asynchronously set something up. But what we are going to do is just use the normal setup one without like setup with error. And you can see this one does not throw, but this one does. So you could do, if your setup code basically failed, you would be able to throw the error at this point and like your test wouldn't run. Or you could have them run if you wanted to. But we are just going to use setup and teardown. And I gotta spell it right, oh my goodness. Teardown, and be sure, see there's 2 of them, make sure you click the one that says provides an opportunity to perform cleanup after each test method in a test case, as opposed to the one that says perform cleanup after a test case ends, not after each test method. So that would mean test method is one of these, like every single test is a test method, a function, as opposed to the entire test case is your class, meaning XC test case. So let's go ahead and put those there, and let's have our app do something because right now it doesn't do anything, but we're not going to do like you're really using SwiftUI. We are just going to make a simple like math calculator program, which is what a lot of tutorials show you, but they don't actually, it doesn't go more in depth than that sometimes, but we will do this so you understand the basics of unit testing and then go in, like see what it really looks like in a real project. So let's first create a new file. So I clicked on the folder, then clicked Command N for a new file, and let's make a Swift file. And be sure we are in our we are in our project right here when we do this. Let's call this simple math and hit enter. And you can see the target that was selected, which I already made it go away, is simple math, is the project CWC unit testing. So we are not in our test target right now. Okay, let's create a new class and we will call it simple math. And then what this is going to do is pretty simple. We will just have a function called add 10, and all it's going to do is accept a parameter called number. That's an integer. And then what we are going to return is number plus 10. And that's it. And let's also make another one here called func. Let's call it b square and we will return number times number because that's how you square a number. And then actually up here as well, we will return an integer. So both of these return an integer. The first one, all it does is add 10 to whatever number we pass into the function. And then this one does the same thing, but instead of adding 10, we're just multiplying the number by itself. So we're squaring it and then returning the number. And then I just did this because it doesn't really matter. Where if we have an underscore in front of the number, you'll see at the call site the word number doesn't need to be there. So when we go to actually test this, what do we want to do? We want to test our class called simple math. So let's make a variable for simple math. And it is of type simple math. And we want to force unwrap it, otherwise it'll have us create like an initializer because this is a class, but that's not how we want to do this. We want to initialize it here. Whoops, not lowercase s, we need a capital S. We want to initialize it here when we start every new test. So that'll happen here, and then the teardown, when we end every test, we will do simple math is equal to nil, because what this does will set it equal to nil after this test example, and then it'll set simple math is equal to a new instance when we run the second test, and then it will make it nil after we run the second test. So both of our test cases will have the exact same environment when we run them. But we are going to definitely just erase this and rename this. So we will test, func, that was weird. Func add 10 works. But we can't just run a test like this, so you'll see if my Xcode loads. So I just built the project to make my Xcode work. You can see when we try to just create a function to do a unit test, it doesn't show anything with just a normal function. The function names for unit tests must start with the word test. So let's change this to test add 10 works, and now it shows up in our navigator, and we have this little diamond next to it. So when you write unit tests, you typically follow a convention called given, when, then, or what is it? Act, assert, arrange, act, assert. So let's do given, when, then, or it's also called, no, it's arrange, sorry. So these mean pretty much the exact same thing, they're just different names for how we do this. So what do we want to do? We want to do given. So given would be let answer, or let's call it expected, is of type integer. And let's just, for right now, set it equal to 0. So we want to do when. So expected should be equal to, not add 10, we have to do simple math dot add 10. And let's give it a very easy number of 10, so that we know for a fact when you add 10 plus 10 will equal 20. And that needs to be a variable, not a constant. So what does assert mean? Assert is saying, let's do something, or assert is saying, what do we expect to happen? So we want to xct assert, let's say this one, that expected is equal to 20. And this means this should be true, this expression, for this to pass. So we want to assert that this happens, so this expression should be true for this test to pass. So let's go ahead and run just this test. So let's click on the little diamond this time. We can see the project building. So you see our project run, and then we see test succeeded because it worked. So this is our project, and this is our like unit testing target project. They both like kind of come up at the same time because we do run our real project. But what we see in the console here is selected tests started. That's because we clicked on this test as opposed to clicking like Command U. It would have said like all tests. And we can see XC test, that is what we ran. This is the class that we were in. And then see all the way over here, we ran test add 10 works. And you can see it started, it passed, and then this says the whole suite passed, meaning this whole suite of tests. And then we go back here and says we executed one test and select a test, executed one test with 0 failures. Yeah. So basically, the test passed, and you can see how long it takes for your test to run as well. And we have the little check mark here, and then that pop-up that shows up saying that our test passed. So that's good. But there's also other kinds of asserts that we can use. So this is just a normal, like, whatever expression is in here, if this is true, this passes. If it ends up being false, then it fails. So if we change that to 21 and run this again, we know we add 10 to this number, which equals 20, but we are saying expected should equal 21, which we know that won't work. So we get a test failed. We have an X here because our test did not pass, and then there is an X right here because one of the tests in this whole class did not pass. And then you see up here, that is an X as well because the whole suite, there's something that's failing. And then same thing down here, we see something failed. And then all this says is XCT assert true failed, which is kind of not useful sometimes. So you can even add another parameter right here. So if we put a comma and we add something, this is what it will say when our test fails. So let's say this should be 20. So if we run our test again, and we know this one is going to fail because this should be 20, not 21. It goes, it runs, we get test failed, and then when we actually click on this here, now it tells us XCT assert true failed, this should be 20. So it's really easy to debug and see like what should have happened, as opposed to just guessing like it just says failed and you're like, well, I don't know the reason why it failed. But another thing we can do, let's first change this back to a passing test. There's other asserts that we can do. So we can do, you could see this actually runs XCT assert true. So if we do XCT, there's a lot of different asserts. So let's do XCT assert true. Expected equal 20, and this one is pretty much the exact same thing as this one. So this expression is the same as this expression here. But an even better one that we can use that like really helps solidify what this does and what we are like trying to accomplish with this test is XCT assert equal. So what we can do is this one is XCT assert equal, and this really takes 2 parameters, but I added the third of this is again the description, so that's the same as this part. I think it comes up as if we command click on this and click show quick help, it actually says message. And it kind of doesn't, so maybe not, we won't look at that. But we look at this, we have the first parameter should equal the second parameter because it's literally XCT assert equal, assert that the first value is equal to the second value. And we can have multiple assert statements within a single test. So let's go ahead and run this, and we should get test pass. And there we go, we have test succeeded, and we can see also that we ran just our single test. And let's make a test for the other function that we did. So let's test that b square succeeds. So let's do given when then. We'll do var expected is equal to 0. So we don't really need that integer part there, I just kind of put it there. And then we want expected is equal to simple math dot b square. Let's do 4. What is it? 4 times 4 is 16. And I have to spell expected right for anything to work. And then again, we could do an xct assert equal, and so make this one shorter. And we expected should be equal to 16. Whoops. There we go. So it's pretty much the exact same thing. We run this. And then we should see in our console that now we have 2 tests that are running, not just one. Or no, sorry. This is just one test running because I only clicked the little button here. Yep, executed 1 test. But if I went to click the class up here, or just click the little play button at the top of like our whole unit testing suite, okay, we see that 2 tests were executed and they all passed. So 2 tests, 0 failures, and all tests pass. That's awesome. So what this really helps you do is, this is very explicit of add 10 and b square. But if somebody, for example, forgot what square meant and thought that square meant number times 2 and thought that the person who wrote this was just completely wrong, when you go to use your code base and merge your code together with others, if we ran our test again, we will see that one test, our add 10 test, works, but our b square test will fail. So there we go. We see it. The pop-up tells you tests failed because not everything passed. But we see one of them worked, but the other did not. And then we see down here, it just says xct assert equal failed. 8 is not equal to 16. So expected is the 8, and then what we think it should have been is the 16. So that's how you can prevent others from like messing with the code and then you not knowing something happened. You can use unit testing. In this series, we have learned the basics of unit tests. We have learned that every unit test must begin with the word test. We have learned about setup and teardown methods, and then also about different kinds of asserts. So in the next project, we will add unit tests to a project that doesn't already have them, and write unit tests for more applicable code other than just adding numbers together. See you in the next video.